All right, this is a brief introduction, largely just by example, of how to use the do file editor and make actual do files in your analysis. I've noticed that many of the tutorials, so there's like a billion Stata tutorials online, but they seem to be a bit light on using the do file editor and they're sort of explaining what it does, which I think is a huge mistake because although it's possible to do use Stata at the command line and just sort of go along doing stuff and seeing what happens. The problem is, as I've said in other videos, that makes it very hard to basically replicate your results. You'll wind up with a case where you have all these great results, this analysis, you've seen it, but you're never able to make the data do that again, and you just don't know why. And at that point, people start to wonder if really all your results are just an error, and you can't prove otherwise because you don't have the code that created it. So as a matter of fact, it might seem a little weird and unfamiliar at first to use the do file editor, especially if you are not used to writing code, but pretty soon you will see how wonderful it makes things. Your life will be a lot better if you do this. All right, so the way I'm going to do this is to just walk through some very simple analysis. We're just going to make some simple graphs using data from an actual project that I have with two of my PhD students. Now this project, the overall goal is to see if, try to measure the impact of climate change on political power and the distribution of political power. So we have a lot of data on things like climate, weather, and on election results, and as well as on candidates who stood for office. So it is this latter data set, the candidates who stood for office and information about them, that we're going to look at today, just poking through that data. So first thing you want to do, so typically if you were approaching a project or say a new project, I want you to look at a new data set, you would make a folder, probably on your Dropbox folder, I hope, that will contain all of the data, files, etc. associated with this project. In this case, since it's an existing project, we already have that. So this is our project folder, and so just going through, you can see we have everything split up nicely. So this folder data is all basically raw data. So this is the form that we get it from either the internet or wherever we found it. We have a file here, do. This contains all of our do files, so all of our code. You can see we have quite a bit. We're going to have even more after today because I'm going to create a new one. And then we have this file, this folder here, the DTA folder. This contains all the Stata format data that we're going to use. So the data set that we're going to look at in particular is in this subfolder here on affidavits. All right, so sort of keep that in mind. That's sort of our goal. So there's a bunch of other folders in here. I'm not going to address the other ones because these are the ones that you're most likely to sort of deal with. A folder that contains your raw data, a folder that contains your do files, your code, and a folder that contains the Stata DTA file. So as you're processing your raw data, you may want to save DTA files, or you may be lucky enough to get the data in the form of DTA files from the start. All right. So first things first, whenever we work with code in this lab, whenever we work with Stata, not just Stata, but also Python or anything else, you want to start with a template. So you can see here we have a template. This is in the Dropbox lab folder. There's an equivalent, an analog that you have access to. So take this template for the do file, bring it over here. I'm going to just copy it in so it's wound up over here. Now I'm going to rename it. How do I rename it? Well, you can see all of these files are named using a common convention. They have what I call a project stub. So in this case, the project stub is climate power. Every file starts with that. It tells us that this do file is related to that project, right? It happens to be that the name of the folder also is that project stub. It's kind of useful when you come back to code, say 1, 2, 3 years later, to have everything sort of named so you know what's relevant. So I'm going to call this climate power, and I'll put an underscore, and then give it a name that's sort of a description of what it does. So here I will call this candidate stats, because this is going to look at statistics, calculate statistics related to candidates. And so let us pull this up. So when we load up our do file, so we want to open the do file editor as I've shown you in a different video. And so now pull this up, load it into Stata, and so you can see this is our blank project, our blank template. And so the top here, you have a bunch of comments. So anytime you see this slash star and then a slash star at the end, it means a block comment. So everything in here is going to be ignored by Stata. It's just there so that a user who comes along can sort of read what's been done. And so I want to really push you to use comments like this. There are two types of comments. One is the block comment, so everything in between this and this, Stata ignores and it makes green, so you can sort of, when you come back, you can read it and notice it immediately. The other type is this type, that's slash slash, so you have two forward slashes. Then everything on the line that follows is a comment, but then the next line is not necessarily a comment unless it's also got two slashes in front of it. All right, so start out by basically putting your project, your file name over here, just so that we know exactly what, when we get into this do file, we know what it's related to. All right, here, that's very easy. Now we want to give a description. The description I have for this is this file creates figures that describe the candidate wealth data. Right, so that's sort of the data set we're working with. Then we want to give the date it was created, which today I happen to be making this video on January 10th, 2017. So 2017, 01 for January, 10 for the day, created, and your name. So I just put in an @ I'm lazy, but you would probably want to put something a bit more descriptive. There's only one @ in this lab, so unless you have a really catchy nickname, you can make a new one. Next, you want to, so don't worry so much about what this code over here does. It's programmed to sort of work, and it just sort of works automatically. But one thing I do want you to do is come down here where you see again that project stub underscore file stub, and just copy and paste the name of your file there, right? Without the extension, ideally. All right. Now, one other thing. So over here, it says this if machine equals blah, blah, blah. So this, I'm not going to go into the details of what these things mean. If you're interested, you can see my video on macros in Stata. Instead, I'm just going to tell you, so over here, you should put in this machine, in these quotes, you should put, say, perhaps your name. So I will just put @work so that we know it's Ajay's work computer. I'm going to put that there. And then over here, I'm going to copy that. So this is saying if I'm on the Ajay work machine, run this code. And so here, I'm just going to define so I know I'm being really big on what any of this means. So this stuff here is not as critical to what you're doing. It's just really useful. So you can just sort of follow what I'm doing here, sort of mimic it, and you will get it right. So here I'm just going to define a global called path. And here what I want to do is put the path to the project on my computer, right? So the idea here is that I don't want to, if somebody else, say one of my co-authors comes along and wants to run my code, they're going to have all this stuff in different places, right? A given folder isn't always going to be in exactly the same place on different people's computers. So the idea here is I can just take this, the path for the project, put it here, and now anytime I use path with a $sign in front of it, it'll just refer to this. All right. Again, if you want to see the details of what all this means, you should see my video on macros. All right, so now we have a path defined. That's all fine. And so now we can see here, skip all of this, don't worry about it. This is where we put our code. So again, we have a block comment, right? So Stata's got to ignore all this. This is just here so that when we read it, we can sort of break up our code in a sort of nice, logical manner. So the first thing we want to do, so what I want to do here is first start out with overall stats. What I mean by that is I want to first look at statistics about all candidates, so candidates in general, And then later on, what we're going to do is stats by cast. So we want to look at different cast groups and see if they have different, um, if some of these variables differ by cast. So on average, some casts are different than others. All right, so the first thing we want to do is load up the data. So what do we do here? So we use and quotes. I'm going to pull up the path. So this is how you should call the path variable here. So this, again, as I said, I keep on repeating this. I'm being really vague about what this means. Just sort of take my word for it. One thing I want to note, in Stata, it's a lot better to use forward slashes instead of backward slashes. So I know if you're using a Windows machine, like I am, when you pull up this and you try to copy the path, everything is using backslashes. I suggest that when you pull it into Stata, you switch it to forward slashes as I did. It just makes things work a lot better. All right, so now we have our use command. Remember, use is Stata's command for pulling open or opening a data set. So I say use the path. So Stata is going to read that and then load in the project path. It's just going to read that and see it as this. All right, so we're already here. Now we go in with the data file we want, DTA/affidavit. And so this is actually the file we want here. And so if you go to properties, just in case, again, if you're using a Windows machine, you can see it sort of lists the entire path here. So we've already got this part covered. You don't have to worry about it. So it's just this part here. So really, we're going to say in the project path folder, in the DTA folder, there's another folder called affidavit. Right. And so the file we want here is this one. So this is the one I'm interested in right now. Obviously, in your project, that would depend on the project. I'm going to do that. I'll use the sub option clear. This just tells Stata if there's already a data set in memory, you should clear it, get rid of it, and we're interested in this one now. All right, so if I take this, let me just split screen this here. We can watch what's going on. If I run this now, run this entire thing. So we go over here, and so you can see it's done this. It's run this other stuff. This is all comments largely, so it doesn't really matter. One thing Stata is doing in the background is opening a log file. Don't worry about that right now, but just so you know, that's what all this crap means. So it's opened our data file, so now we can describe it and see we have all these variables. I was not so great about labeling some of these things, but we're in luck because I sort of know what they are. So here we go. Let's blah, blah, blah. All right. So let's start out by looking at the assets here. So the first thing I kind of want to do is just sort of get a sense of what this looks like, right? So let's look at the distribution. So the k-density command. So if you type in help k-density, so it'll give you a help file on this so you can see all the syntax. I know it all, or, well, not all, but I know enough to use it right now. Basically what this will do is draw. It will try to draw the distribution. So try to take the data and smooth it to form some sort of distribution. So the first thing I want to do, so as usual, if you're at the command prompt, you could type something like k-density. Let's say we were interested in the total assets. So you have to pick a continuous variable for the k-density command, right? It doesn't make sense to do this on something that's discrete, but something like total assets. So this variable is basically the all the assets, the value of the assets owned by the candidate. If I run this, it comes up with a kernel density estimate. Now this doesn't look great because there's really, really big outliers here, right? So if I summarize total assets with some detail, I see here I have a lot of really crazy outliers. So if I wanted to, I could just take this over here. So say k-density total assets, right? It's exactly what I did a moment ago. So that same code, the command, I can literally just copy and paste it here. Now if I run this file, Stata will do all of that, load the data set and make this kernel density estimate for me. This doesn't look so great. So what I'm going to do here is actually use a conditional. You should look into the other resources I've given you if you want to learn more about using conditionals. But here, what I'm doing is I want kernel density. I'm going to sort of restrict it so that it is only looking at these lower values here. So let's suppose that, so when I type summarize, it tells me the first, fifth, 10th, 25th, 50th, et cetera, percentile. So basically, let's suppose I restrict to the everything below the 75th percentile. So k-density total assets, if total assets is less than this value here. All right, so I'll just copy and paste. Now let's run this. So one useful trick, if you select a block of code, and so if you're at a Windows machine, you would say Control D. If you're at a Mac, I believe it would be Command D or Apple D, one of those two. Actually, I guess Apple and Command are the same key, but anyways, you could basically select this, and if you do Control D, it'll only run this part, it won't run the rest. So now you can see it actually comes out a lot nicer, right? This looks like sort of like a, density. So that's not bad. So that's one thing you can do here. And so let's say I'm going to type some comments. Remember I said 2 slashes is a 1-line comment. So I want to describe what this command does. I say, density of assets for lower 75%. All right. Now let's suppose I want to make a scatter plot. So you've all seen scatter plots at some time or another. It's very easy to make a scatter plot in Stata. So next thing I want is scatter plot of assets versus liabilities. Right, so we have not just their assets here, but also their liabilities. So how do we do that? We use the scatter command. So scatter, say total assets. So Stata, for whatever reason, you give the y variable first and then the x variable. So here I'll put liabilities against assets. So I do this and I run it. See, Stata makes a scatter plot very quickly, and so we have assets on the x-axis, liabilities on the y-axis. Now, unfortunately, again, this has a lot of really crazy outliers, and that makes it a little bit hard to read. So let's suppose I restrict things so that we are looking again at things down here. So just people without as many assets. Unfortunately, this restrict things on the x-axis, not so much on the y-axis. So what we can do here is also do a restriction on liabilities. All right, so just like I said, I want total assets to be less than this, and also say I want liabilities to be less than a value. So I could go through, summarize again, and find the 75th percentile of the liabilities. I'm feeling lazy right now, so I'll just take the same value. Let's just go with it, see what happens. And there you go. So this doesn't look great, but it is a scatter plot. And so there we go. That is, in fact, the scatter plot here. All right. Another thing we might want to do is maybe look at net assets, right? So looking at assets and liabilities separately doesn't necessarily make sense, because in some sense you could have a lot of assets but have huge loans. So in fact, you might not really be that rich. So one thing we might want to do is look at density of net assets. How do we do this? So first we have to actually calculate net assets, right? That's not in our data set here. So if you look through, you'll see there's nothing like net assets. So to do this, first I need to generate. I could have also said gen. So if you look at my code, oftentimes I'll just use the shorthand of gen. But right now, just for instructional reasons, I'll write it out fully. So generate. I want to generate a new variable. What's the name of that variable? It will be net A. I define that as total assets minus liabilities. I'll run that, it generates it. So now we have a new variable net A. I can summarize it. So you can see most people have a positive value for this, but some people actually have a negative value. So some people are just really far in debt. And now I can do a kernel density of this as before. And now I'm putting the name of the new variable here, right? And this looks really weird, right? Because we have these huge outliers. So most of the data is down here around 0, but we have some huge outliers, really big negative values, some huge outliers that are big positive values. So what I'm going to do is, again, use an if statement. So what I really want to do is say, all right, I want to restrict to cases where the absolute value is, say, less than, a couple million or something like that. So here we had about 6 million or something. So let's suppose, so what I want to do here is if the absolute value of net A, so abs is the function that means absolute value, and then in parentheses I put net A, so this says the absolute value of net assets is less than 1 million, so this tells Stata to throw away those. So you can see this is what it looks like, right? That's not bad. And again, I want to emphasize what is the benefit of doing this in a do file. It's that, well, if I want to go back and change my definition of net assets somehow, so let's suppose maybe I want it to be 3 times this. I don't know why you would ever want to do this. I can do that. I can make that change over here and then run this again. Everything runs again and it produces all this figure again, right? So we get back to this. This is if we had some reason for wanting this weird definition of net assets that is 3 times the actual value, it would look like this. And it's very easy to make that change, right? So that's not actually what I want to do. So let's change it back, get back our original graph, and that's where we are. Boom. All right. One other useful command is the hist command. So I've shown you k-density so far. Sometimes it's useful to draw a histogram instead. So I do histogram net A. Let's suppose I look at that. So here it's sort of made a smooth distribution. Sometimes we just want a histogram. So I'm not as worried about having it smooth. I can run this and see this is what it would look like as a histogram, right? All right, so many other commands you can use if you're looking at your data. I'm not going to get into them right now. You can check all of those many resources I've shown you before. Next thing I want to do is try some stuff by cast. So I'm going to be really brief here, but one thing I want to do, so in the data here, we have this variable, candidate category. So if you tab this, so tabulate, tab is short for tabulate, see it gives a bunch of categories, Gen, SC, ST. What this stands for is SC means scheduled cast, so people of really low tribe, really disadvantaged castes, historically disadvantaged castes, they're marked as scheduled caste in this data set, right? If you are of a scheduled tribe, ST, it means you're of a historically disadvantaged tribe. So these folks are, they've suffered a lot of discrimination historically, and so you would expect maybe their outcomes would be worse. They would not be as well off as these people in the general category. So Gen stands for general. These folks are have not suffered any historical discrimination, at least according to the Indian government. So one thing we might want to do is look at these different categories. So maybe average income assets by caste. So suppose I want to do that. We could say, so average net assets. So we just calculated net assets. Let's use it again by caste category. How do we do this? I can say graph bar. So this set of commands here, what is it? Type in help. It'll pull it up for you. So it says that it will generate a vertical bar chart, right? So you've all seen bar graphs. So what do I want to do? So I could just do graph bar net A. This is not a very interesting bar graph. It's just going to give you the average net assets in the data set. That's kind of lame. So what we really want to do is combine this with the comma, with the subcommand over. So if you type comma, that tells Stata you want to give it some options to the command you just gave. So suppose I want to put this over, and so put a cast category in here. This tells Stata to make a bar graph where it will generate a separate bar for each value of this thing in here, which happens to be cast category. There you go. See, now it gives you the average net assets of each of these cast categories. So you can see people in the general category tend to, on average, have net assets somewhere around 1.5 or 15 million. Whereas people of scheduled caste, the disadvantaged castes, are a lot poorer, right? Considerably poorer, fewer assets. Scheduled tribes are somewhere in the middle, right? And as I said before, it's in a do file, so you can just rerun this anytime we want, see everything again. That works out. Perhaps, instead of doing this by caste, maybe we would have wanted to do this by gender, right? So we can do that, change that. It's in a do file, so we can just run it again, change this one thing, and we can see, okay, interestingly, on average, female candidates, women running for office, are wealthier than men. Of course, both of them, they're all wealthier than the candidates who do not specify a gender, right? All right, and so that is a brief overview. Let's change this back to caste because that's what we said we were looking for. But all right, so this is a brief overview of how to use the do file editor, especially for something like exploring the data, which is something you will probably, it's very likely you'll have to do that at some point. So if you want more details on this, on all these commands, what all this means, take a look at my other videos and take a look at the resources I've linked you to.